Right, so this is a slightly different example. They want me to calculate the average nitrogen to hydrogen bond enthalpy in ammonia. They've given me delta H formation and they've given me some bond enthalpy. So I'm going to use Hess cycle to work this out. So if they've given me formation, what's the equation for formation? Well, we can write that down. If you remember, the enthalpy formation is where I want to make 1 mole of ammonia, so that's NH3 gas, from its elements in their standard states under standard conditions. So I've got to get this to balance, so I'm going to have to use a half N2 and 3 over 2 hydrogens, like so. And that is delta HF, so on that arrow I'm going to put minus 46. That's what that refers to. They've given me bond enthalpy, so what goes down here? Down at the bottom goes the gaseous atoms. So down here I'm going to have nitrogen atoms and hydrogen atoms. Like so. I'm only going to have 1 nitrogen atom, but I'm going to have 3 hydrogen atoms, like so. Okay, you have these so far.
Why is it not put in groups like N2?
Because when I use bond enthalpies, the bond enthalpy is creating it from the gaseous atoms. It's creating the nitrogen bond from the gaseous atoms rather than if we were using formation data, it would be from the elements in their standard states, but bond enthalpies is from the atoms. So. Right, and my arrows are going to go, what, up or down for bond enthalpies? Bond enthalpy, is it making or breaking a bond that I measure? Okay, so my arrows are going to go down. This arrow is related to 3 NH bonds because I'm breaking 3 NH bonds. This arrow, I've got half an N2 bond, so it's a half times 944 plus 3 over 2 times 4, 3, 6. So just think, just times the bond by that number. Right, we'll whiz through that and see what we get. Okay, so this comes to 1126. Yep, we're happy with that. So let's do the equation. So here's my circle. These 2 arrows are going the same way. That arrow is going different. So 3 NH bonds minus 46 is equal to 1126. If I bring the 46 over to the other side, that means that 3 NH bonds is equal to 1126 plus 46. What does that equal? 1126 plus 46? 1172. Okay, remember that is 3 NH bonds. So each NH, I have to divide that by 3. So that equals, what is an NH bond? 3. Okay, so 391 kilojoules per mole. So the idea of this question is it's given me delta H for this reaction. It's given me some bond enthalpies here, and it wants me to calculate the carbon-carbon double bond. So down the bottom, I'm going to put the gaseous atoms. I've got 2 carbons, and I've got 6 gaseous hydrogens, like so. Okay. Once I've got that, I then need to put my arrows on. So my arrows go down. On that arrow goes my minus 138. Yep. Because that's delta H reaction. Right. On this arrow, I'm breaking 6 and one carbon-carbon bond, which is 6 times 412, plus a carbon-carbon, which is 348. And that comes to 2820. On this arrow, I'm breaking one hydrogen-hydrogen bond. I'm breaking 4 carbon-hydrogen bonds and a carbon-carbon bond. So that equals, a hydrogen-hydrogen is 436, a carbon-hydrogen is 412, so 4 times 412, 1648, and the carbon-carbon double bond, which I don't know. So on total, that equals 1 carbon-carbon bond plus 2084. So I've just added all of these numbers up and I've added in my carbon-carbon bond, I don't know. Right, I'll do my little circle. I've been a little bit crazy on the numbers there. Okay, so this and this. So I now go minus 138 plus 2820 is equal to 2084 plus my carbon-carbon double bond. If I rearrange that, so that's minus 138 plus 2820, and I'll bring over the minus 2084, that means that my carbon-carbon